Good afternoon, and welcome to the ALCTS webinar, Introduction to Python and PyMARC Session 2. I'm Eva Sorella, member of the ALCTS Continuing Education Committee, and I'll be your host for today's webinar. Our presenter today is Lauren Magnuson. Lauren is Head of Collection Management and Technical Services at California State University San Marcos and Development Coordinator for the Pawnee Library Consortium. Her interests include PHP, Python, analytics, data visualization, and open source technology in academic libraries. She is the author of several book chapters related to library information technology. Lauren has a master's in information science and a master's of education in educational technology. Her presentation today will focus on how to use the Python programming language and specifically the PyMARC library of code to transform library metadata and make technical services workflows more efficient. A few things to keep in mind for today's presentation. Today's webinar does not have interactive chat capabilities. If you wish to comment on today's presentation using Twitter, you may use the hashtag you see on the screen. We will not be monitoring the Twitter feed. If you have questions for Lauren, please type them into the question box on your screen, and she will answer them as time permits at the end of her presentation. Questions which remain unanswered while we are on the air will be answered offline and the answers sent to all attendees. This webinar is being recorded, and you will receive an email with links to the recording, the presentation slides, and an evaluation within 2 days. Now, there may be a slight delay as I turn the presentation over to Lauren.
Hi, everyone, and thank you all so much for coming back to this second session on Python and PyMARC. So this is session 2. We're going to do a deep dive into using PyMARC and the scripts that we shared last week. So I do want to do a quick recap of last week's session, which was session 1. In that session, we learned how to install Python and PyMARC on your computer, and I've received many questions over the course of the week. People running into weird things on their computer or some changes they had to make. I have been updating the instructions on the GitHub repository for installing Python with some tips that other users have found working in their environments. So be sure to check out that updated version if you are just getting started installing things. We also talked a little bit about running scripts using a command line interface, so PowerShell on Windows and Terminal on a Mac. So I'm basically anticipating for this session that you've either taken a look at that or you know basically that's how those scripts are going to be run. And then we also went over just very briefly what is included in the GitHub repository of sample scripts, which has been updated since then with some additional scripts. So we'll talk about some new stuff this week, as well as a deep dive into syntax and getting started with programming. So in this session, we're going to talk about a few very specific things in great detail. First of all, getting fields from MARC files. So a really common workflow using Python and PyMARC scripts is to take some file of MARC records, extract a whole bunch of fields out of it, manipulate those fields in some way. So we'll talk about getting those fields out, handling missing fields if you're looking for sort of variable data fields that may not be in every record. PyMARC intuitively doesn't handle that very well, so we'll talk about how to handle that. We'll manipulate fields and string data using some common string manipulation techniques. We'll talk a little bit about looping through records and fields and sort of conceptualizing when you need to run a process multiple times over multiple fields and multiple records. How do you structure your code to handle that? Then we'll look in a lot of detail at writing data from MARC records to a CSV file, and then the opposite, writing data from CSV to MARC. So let's get into it. Okay. So this first example, this is from the very first script in the GitHub repository that I mentioned last week, this oclc1.py. This script is a very basic script that is actually taken directly from the example that came with the PyMARC library. If you looked at there's a PyMARC GitHub page that has instructions for installation. So this is basically what the developers of the PyMARC language kind of provide as an example. So I'm going to talk about each piece of this small script and what each of these things mean. So first of all, at the top of the script, you'll notice something that says from PyMARC import MARC reader. And what this is Python, as we mentioned last week, uses modules, and PyMARC is a module, to sort of augment the base Python code language. So in this case, we're taking the PyMARC module and we're specifically using a module called MARC reader. So in this case, we're wanting to print, just in our terminal application, all of the OCLC numbers that are in the file. So in the example file that I have included in the repository called mark.mark, I think there's 6 records in there. So I'm using this syntax here, open with open mark.mark, and then this these 2 letters RB as FH. Okay, so what does this mean? Basically, I'm telling Python to open a file, that's mark.mark, and open is a built-in function in Python that has a whole bunch of other functionality behind it. And this particular syntax is following that syntax, or that, that functional requirement. So we're opening the file. RB means read binary. So basically we're saying, with this file, open it up and read it. And by the way, it's a binary file. And then we're storing this whole kind of action of reading the file as this variable FH. FH is something that I totally made up. I think it's actually from the original example that's included, and I just reuse it in all my scripts. You could swap FH out with anything, with file, or probably not file, but file type, or new file or something. You could basically use anything. But you'll often see in Python examples just either 1 letter or 2 letters, kind of storing it as a variable. I'm going to use the word variable a lot in this presentation, so I'm hoping that people understand what that means. It's basically storing some bit of data, some setting, some constant that you're then going to reuse and reference. So here I've stored my sort of open file as FH, and then I'm referencing that in my next file where I'm creating a new variable called reader, and that's going to be that MARC reader function referenced up here, which is going to do reading basically on this open FH file. So hopefully that all makes sense. As you start working with Python and PyMARC, you really will think, you will not give any of this a second thought. You know, this syntax is something that for many months and even years, I use this kind of syntax without ever thinking what any of it means. I was just copying and pasting it from other scripts that I had used and reusing it. But basically what this boils down to is that we're opening a file. Our MARC reader module is going to be reading the file so that Python knows that we're dealing with MARC records. And then this next bit is where we're starting to loop through or iterate over the records. So for the record in the reader, so notice again, the reader here has been defined up here. Record is actually a built-in type of thing that PyMARC understands. So PyMARC knows what a MARC record is, and it knows how to identify in a certain file where one record begins and another ends. So this has this record use is not a variable here. This is a particular meaning that is embedded in the PyMARC code. So for each record found in the reader defined here, we want to print, and again, that has specific meaning in Python. In Python, print basically is telling your terminal output or your server to just output data onto the screen or into your terminal application to print the record 035A. And this way of referencing a field, the bracket use here, is what you'll see. You'll use this again and again and again. Basically the syntax of record, open bracket with the individual quote 035 as the MARC field, and then the next bracket set is going to give you the subfield, again in quotes. So all of the syntax is very precise, and you'll be reusing this many, many times. Okay, so you've run that. Let's say you've run that script. What you should have seen on the output is a whole bunch of 035 fields. What happens if fields are missing in one of the records? So you have a whole bunch of files from a vendor, and maybe half of them have OCLC numbers. Half of them have no 035 fields at all. If you ran that script that I showed on the previous screen, if you just ran this on a file that had a mix of some records have 035 fields, some do not, this is what you would see. You would see this very unhelpful type error. None type object has no attribute get item, which I'm sure sounds just completely meaningless. But what's happening is essentially Python looked for a field that doesn't exist. So you told Python to go look for an object, the mark 035 field, but there wasn't one there. So Python didn't know how to get the field that you asked for. The object doesn't exist, so it doesn't have a type. So there is some logic to that error. It is actually telling you what the problem is, but it might seem like an incomprehensible error. I will just as a reminder, you know, when you run into errors like this that are just like, I have no idea what this is saying, this is a great thing to just throw that guy into Google and see what likely Stack Overflow has to say about it, because you'll probably get people running the same issue, maybe not using PyMARC, but using other Python language modules that will be able to help you out. But basically that's what's happening here, is that we didn't have that record in, or that field in one of the records or more of the records. So how do we handle this? We basically need to write in a conditional, which is an if-then statement, to look for an 035 field and only tell Python to print it out if it exists. So if you're familiar with like creating lists in Millennium or anything like that, and you've probably created criteria or like Boolean search criteria, if it's not null, right? It's that same idea. If the 035 field is not none, if it exists, then print the 035 field. You have to be very, very literal with Python. So I've been thinking a little bit about this analogy that I use when people are frustrated with programming languages. Working with programming languages is like building a rocket ship with a puppy who's really good at math. So it's like you have this puppy who's really well-meaning and wants to help you out, but only takes instructions extremely literally and also has no idea what a spaceship is or what space is or any context about what you're trying to do. So you have to be very direct and very clear in what your instructions are. Otherwise, your puppy is going to give you a bunch of none-type errors that are incomprehensible. Okay, so this is what the script should look like. And I did include this modified version of the script in GitHub. It's called oclc1_missing.py, and you can run this against, as I included my modified MARC records that have some missing 035 fields, so you can see what happens. So now we've just modified this. We've got our same, everything is exactly the same. We're opening the file. We've got the reader statement in there using MARC reader. We're looping through the records using for record and reader. And then we have the statement, if the record 035 is not none, then print it. You could also include an else statement here. So an else condition would, and I have an example later in this presentation, you'll see what else looks like, but you could add an else at the end that says, maybe when you output your CSV file of records, you want to know and identify which records did not have 035 fields. So you could put an else condition that's just like print no 035. And then when you open that file in Excel, you can filter each of those rows to see exactly which records were lacking an 035, if that makes sense. I also, in most of my examples that I'm including, and you'll see this in the more extensive scripts that I'm providing in the GitHub repository, I'm not only checking for the existence of the field, so in this case 035, but I add yet another conditional underneath. Notice that it's also indented again. And basically Python's going to read this logically. It's going to start with for record and reader, then go to if the record is 035 is not none. If that condition is met, it's going to go to the next conditional. If the record 035 subfield A is not none. So this obviously is very unlikely to happen with 035 fields. But if you're working with any other subfield, so like let's say you're looking at 245 fields and you're trying to get author statements from the 245C. Well, most fields obviously are going to have a subfield A, but with fields that might have variable subfields, they may not have a 245C. So this is the syntax you would use to check to make sure not only the field exists in the record, but that the subfield exists as well. So again, that's less important in this particular example with the subfield A, because it's always going to have an A for the most part. but it's really important if you're working with fields that would have more variable subfields. Okay, so we had this activity to look at this particular script, OCLC2.py, where we were looping through some conditions, looking for particular bits within an OCLC number that we would want to replace. So if you remember from that example, our file of MARC records has OCLC numbers in them that have OCN prefixes, OCM prefixes, maybe OCLC in parentheses. You've probably seen this if you've worked with OCLC numbers before. And so this is one conditional located in that OCLC2.py file where it's looking for a particular bit of data in the 035 field. In this case, we're looking for OCN, and we want to replace that with nothing. So our goal is to end up with just the OCLC number. No prefixes, no OCOLC, nothing, just the number. Okay, so what's happening here? We have a conditional. Here's my if-else. Note the alignment of the if and else, that these are in the file. They are aligned very straight on the side there. That's really important. That way that else statement is known to be associated with this if. So if OCLC number, which is where we've stored our 035 field in this variable, this is a variable name that I created. We're using this find function. This is another built-in Python function. Look for this string statement OCN, and if that is greater than or equal to 0, then replace it. This is another built-in function here, method, with nothing. So replace what we found OCN with just blank data here. Okay, so I'm going to talk a little bit about why this greater than or equal to in a minute, but I just want to talk through this example. There was another conditional in that same file, and we had a little assignment as part of the GitHub repository that asked us, how can we adjust the OCLC2 script to get rid of the OCM prefix in 2 of the items? So if you worked through any of the examples, you might have seen that when you output OCLC2, the file output would include, or the output in your terminal would include the OCM prefix in 2 of the records. And that's because this conditional wasn't quite finished. This conditional is exactly the same as the conditional we saw in the previous slide using OCN. But you'll notice the piece that it's looking for does not match the piece we are trying to remove, which is OCM. So we're trying to remove OCMs. This thing is looking for XYZ. It's obviously not finding them. So in order to fix this, the solution is to swap out XYZ for OCM, the piece that we're actually looking for. And then we're not only going to swap it out here where we're looking for it, but we're also going to swap it out where it's getting replaced. So the kind of translation of this script is Python go find OCM, and if you found it, replace that OCM with nothing. Okay, so what is with the greater than or equal to 0? So the find method is, again, a built-in Python method that you can use. It's not PyMARC related, it's just straight up Python. You can use in a number of scenarios. But what that find method does is it looks at a string of data, so in this case our 035 field, and this is the definition from the documentation, so this is going to sound very abstract, but I'll explain in a minute. The find method evaluates a string, our 035 field, and returns the index position of the match if a match is found. Okay, so if it finds OCN, it's going to tell us where in the string that started. If it doesn't find it, it's going to return, in every single case, a -1. So when I'm saying if the result of the evaluation of the statement is greater than or equal to 0, that means if you come back and you do that find operation and you give me -1, I know you didn't find that field. So why 0? So Python, like many programming languages, is 0-based, meaning that when you're looking at, let's say, an OCLC number, a string of text, the very first character in that string is the 0 character. So let's say it starts with a parentheses. That open parentheses is the 0 character. So if, let's say, our statement finds OCN, and OCN starts at the very beginning of the 035 field, as we might expect, what this statement's going to come back to us with is 0, because it found OCN, and OCN was at the beginning of the string, and so it's telling us that this string exists, and then it starts at position 0. So you can kind of translate this into human speak, as if you were saying, hey, Python, take a look at this OCLC number field. Do you see OCN in the string? And then Python comes back to you and says 15, as in, yeah, I found this, and it starts at position 15 of the string. So again, you know, this might be kind of hard to hold in your brain all at once, thinking about this, and even explaining it, you know, it's kind of difficult to explain. But you'll find as you start using these functions that you don't need to think about them too deeply. You can reuse a lot of this code in a lot of situations. The key takeaway here is that this statement, this find statement, if it basically finds something, you're going to get either 0 or a number greater than 0. If it's false and no match is found, you're going to get -1. Okay, so someone at the last session had asked about starts with. So if you could use some way of determining if a particular string starts with. And yes, you totally can. So that function in Python is just like find. So you use the variable, the syntax if variable dot, and instead of find, you can just swap out starts with. And so I do have just a link down here. There's lots and lots of other built-in Python string methods that you can use that are similar to find and starts with. So you can take a look at that. If you're familiar with Excel, a lot of those will seem very similar to Excel formulas that you may have used. They may just use a different syntax. But you notice with this one is going to return a true or false condition. So you just need to basically, you don't need to worry about numbers or -1 or 0. If it starts with it, then you can, this next line will get processed. It will replace OCN with a blank. And then my else condition here, really what this is doing, I'm just returning the OCLC number as is, which is just the basic 035 field. And the reason that I'm doing this is that there could be, in this particular case, OCLC numbers that have that they're just OCLC numbers. They're totally plain, they have no weird prefixes, they have no parentheses. So what my script is doing is basically saying, you know, look for these strange variations of the OCLC number. If you find these things that we want to strip out, then strip them out. Otherwise, just, you know, if you don't find anything that we need to strip out, just return that OCLC number to me. So that's what the else condition does. Okay, so one of the scripts is OCLC-regex.py, uses a regular expression. So in OCLC2, I had three different scenarios where we were looking for very specific pieces of data: OCN, OCM, OCOLC, which are commonly associated with OCLC numbers. But what if we just wanted just the number? We just want the number. We know we want numbers. We don't, you know, there might be other weird stuff associated with the number that we just don't want any of it. We only want the number. So we can use a regular expression to do this. So I've got another conditional. I'm using my find method again. And in this case, the records that I'm providing are from our ALMA network zone environment. They have these strange suffixes at the end to indicate that they're part of our ALMA network zone. You don't need to know about that, but just in this example, we have this other sort of weird thing that's a part of these 035 fields in the sample MARC records. So in this condition, I'm saying, if you find this weird statement, get rid of it. And then I want to use my regular expression, which is re, is the Python library, RE, regular expression, which is, if you look at the OCLC regex.py file, you'll notice an import re statement to use that module. So this is the regular expression that we're using. We're substituting anything that's not 0 through 9 with nothing in our OCLC number. And so notice here too the way that these are aligned. I've got these two different sort of actions I'm taking. I'm replacing this statement, and then I'm also using this regular expression to replace anything that's not a 0 through 9 with nothing. I have this else condition, which is doing the same thing as this statement. Now, I'm doing that because in this particular case, I'm looking for O35s that might have the 0-1 CALS network, but there could be O35s in my file that don't have that at all. I still want the regular expression to clean up anything that might be there. So my if else in this case is kind of doing the same thing. It's just that this particular conditional is only going to operate on those fields that have that weird 0-1 CALS network in them. And this guy is going to catch everything else, all those other O35s that may have OCN, OCM, other weird stuff. So my output should be just the numbers. I've just got numbers. These are OCLC numbers. Yay. Okay, so I'm going to give you this example because this is a mistake that I totally made when I was working on the script initially, and I couldn't figure out what was going wrong. So let's say we want to switch things up. This is the exact same conditional that we saw in the previous slide. I've just swapped out this line with this line, and now my regular expression is the first thing that is happening, and then the next line is that replacing of the 0-1 CALS network. Okay, that seems like it should be fine, right? We're doing the same exact actions, they just happen to be in a different order. But our output looks different. Our output ends up with these 0-1 at the end. So where's that coming from? It's coming from this 0-1 as part of this statement here that we're trying to get rid of. So the order of things are really important in programming. What I should have done is just like on the previous slide, I'm replacing that 0-1 CALS network first, like get rid of it. And then what I'm left with is just the number plus maybe some other OCM or OCN prefixes or something else. If I do it in the opposite order, then my regular expression strips everything except the numbers. So I've ended up with the OCLC number and 0-1. And then my replace function cannot find this bit of data anymore because we removed, this statement had the effect of removing CALS network from it. And so we just end up with the numbers. So this is just to say, you know, regular expressions and programming in general is very powerful. Remember that kind of puppy analogy, it has like no idea what you're trying to do. It has no idea what the end game is. It's only going to do what you're telling it to do. So do keep that in mind if you're getting sort of weird results or unexpected results. Think logically through each step that your program is taking and make sure that things are being processed in the correct order. Okay, looping. So a loop enables you to run Python code multiple times over a set of objects. So in this case, MARC records and fields. So as I said before, PyMARC knows how to locate individual records within a single MARC file. To tell Python to loop through each record, you use the statement for record in reader. So in the examples I've provided so far, I'm only pulling out one field per record. Just the statement for record in reader. What that really means is that Python is going to go through and look for an O35 field. And if it finds multiple O35 fields in the examples I've given, it's only going to pull back the last one. It's going to find it and it's done. Well, there are many situations like this ISBN-Gobi example, which is included in the GitHub repository, where you want all the fields. So what this example does is, I don't know if any of you have to do this, but frequently, you know, we use the Gobi acquisition system, and a few times a year, we send all our ISBNs to Gobi so that they know what we've ordered potentially through other systems or just what we have in our library, so that when our selectors go to order materials, they'll see that ISBN link and they'll know that we actually already own it, and so they won't go to place the order. So what this example does is it's looking at each record. So this is loop 1 for each record in the reader. And then without even doing anything, I'm already going into my second loop which is for some variable f. I just made that up. Again, you can use whatever letter you like, and then in record get fields. So what this statement does is it's looking for each field, for each 020, for each ISBN. And then again, I'm checking to make sure it exists. Here's my f again from my statement here, my variable. For each field, if the subfield A exists, it's not none, then I'm storing my variable here. It's basically the 020A. So you can think of this f as basically a variable that can be iterated over, not only in each record, not only each record has 1020, but all the 020. So it's very common, obviously, to have lots of ISBNs in a record. If you want to get them all, this is how you would do it. So keep in mind kind of the way that these variables are getting extracted. We're looping over f in this case. We're looping over each of the 020 fields in this particular loop. So if this script is useful to you, basically what we use that for, you can extract all of your MARC records out of your system, output them, and then run the script. And what you'll end up with is a nice spreadsheet that's basically your one column is all of your ISBNs, and the second column is your Gobi account number, which you can input into the script as well. So I know like our workflow here, I think before the script was basically to output everything in Excel and then do a whole bunch of cleanup, because ISBNs, like OCLC numbers, sometimes have a whole bunch of stuff around them that is not actually the number. So the script basically does the same thing as that OCLC script. It's just going to pull back every single 020 field for you. I do also want to make sure to note that with all of these conditionals and loops, the indentation is extremely important. This is basically how Python knows what actions to take under each condition within each loop. So I've not only indented my second loop, because I want it to occur for each record and rater for each field. And then I've got my conditional here indented as well, so that I know that it's going to occur for each field that I find. So for example, this very last statement is part of the CSV output. So we're writing to essentially an Excel file. If I moved this statement, CSV out to right row, and I didn't have it indented all the way, maybe I indented it back here, you might end up with only 1020 fields written for each record. In other programming languages you might be familiar with, the indentation and the spacing doesn't matter as much, because you might indicate sort of a function or a conditional statement using something like brackets. But in Python, it really only knows what to do based on the indentations that you make. So make sure that that stuff is all aligned here. Okay, so as I mentioned in that last, in the ISBN Go, we were writing to a CSV file. So I'm just going to go over quickly what the pieces of writing to a CSV file are. This might seem a little intimidating because you're creating a file out of nothing, but it's actually very straightforward. And once you kind of understand the syntax and the pieces that go into creating a CSV file, a comma-separated values file from a MARC file, you can reuse this syntax in all kinds of situations. Okay, so in these scripts, this is a particular example I'm taking from that OCLC regex csv.py file. You'll notice the file name in the lower left corner there. We are taking those cleaned up OCLC numbers, and we're going to write them to a CSV file. So at the very top of this file, just to note, and we'll go through and I'll show these statements at the very end when I go over that GitHub repository again. But there's an import statement, just like we imported PyMARC at the top. We're going to import CSV. That's another Python module that you'll use very frequently. And then at the very beginning of the file, you'll have this CSV out statement. And this is a variable that's basically going to store the fact that you're writing a CSV file. You're using a method, CSV writer, to open your output file. And I think it's really important to name your files in this way, because often you'll have in a single script several like input files, output files, and stuff. It's really useful to name your file something that indicates what file was actually created. Your CSV writer is going to open the output file. This W means write. We're going to write to the output file. And then there's lots of options in your CSV file. This particular one, we're using a comma delimiter. If you've worked with CSV files or you've ever sort of opened a CSV or tab separated file in Excel, you've seen that wizard that opens up that asks you, what delimiter are you using? Often it's a comma, but sometimes it's a tab or even like a pipe character. You can set your delimiter here however you need to, if you need to use a pipe, that sort of thing. And then a quote character. So this is also something that you'll use in Excel. So let's say that you're using a comma delimiter. When you open that file in Excel, without the quoting, if there was like a random comma in a field, which is totally possible, let's say you're working with a whole bunch of titles and like some book of poetry has like a beautiful comma randomly in the title. By having quotes around your distinct field, that's going to tell Excel, ignore the comma within the quotes. That's all a distinct field. And so you'll never see the quotes. That's something that Excel can read and understand. You would only see them if you opened them up with your plain text editor. You would see the quotes there. Quoting can become a little bit tricky for those of you who might be working in WMS systems with kbart files. Sometimes if you're finding you've output a kbart file and you're getting some kind of invalid statement, try removing the quotes or seeing you might not necessarily need them. So depending on what you're using your CSV file for, if you're using Excel, I would just go ahead and use the quotes. If you're ingesting into some other system that's really expecting plain text, maybe you have another delimiter that you're using, like a pipe delimiter, don't even bother with the quoting. So if you don't do any quoting, you can just leave these quote char and quoting, just leave it out of the statement and just have the delimiter and close the parentheses. Okay. And then just want to note, if you are using a tab delimiter, for a pipe character, if you're using, you can just put the pipe in there in between these single quotes here. But for a tab, it's this little /t. That's how you would indicate you're using a tab delimiter. I will say most of the time, I prefer tab delimited files because of that issue of random commas that can appear within data that are not meant to be delimiters. Tabs are really nice because you're not going to end up with a tab randomly in a title somewhere unless there's some kind of encoding issue. So I do tend to prefer tab delimited stuff personally. Okay, so this next step, we're going to write up just a title row. So I'm this CVS out, remember that's where I'm storing the fact that I'm writing a CSV file. Write row is the method being used to literally write a row. This is a built-in sort of function in the Python CSV module. So this is just, I'm writing a title in my CSV file. So my CSV file is going to have a header row that's title and a CLC number. The next bit of the file in this OCLC regex CSV is, again, I'm looping through each record. And before I even get to the MARC fields, I want to declare my variables that I'm using as blank. And the reason that I would do this is that later, when I'm writing each bit of data into my field, so I'm going to loop through each record, I'm going to look for all the OCLC numbers and the titles. When I'm writing that, if say a title was missing, what I would see is Python would throw me a list index out of range error, which is another totally unhelpful error message if the object is not found for a particular record. So all this is saying is that you want to include this, you want to declare the variables that you're going to be using from within the MARC records, declare them as blank. As you're looping through each record and locating each field, you'll be able to, you'll overwrite the blank value, but basically it enables you to, your script to be able to handle those fields. Okay, so this is a totally opposite use case, but it's similar. So what we were doing before with our OCLC regex CSV file was writing from a MARC record to a CSV file for ingestion in some other system. But this is a use case where maybe we have a CSV file and we want to write it into MARC so that we can load it into our system. So this could be vendor data. This particular use case I have is, let's say, another library, or there's some large donation of materials needs to be loaded into your catalog using some sort of load profile. So you need some MARC records. But the existing data about items is only available to you as a CSV or maybe XML. So I'm going to use the CSV example. So we're going to turn these items into MARC records. We're going to clean up the OCLC numbers like we've been doing. And we're going to add a subfield 9 local to local titles and records. So that's a shout out to my ALMA friends in the network zone environment. You may have seen this example or have this very need working in a network environment. Okay, so I have this screenshot here. This is also this records.csv file is included in the GitHub repository, just like this. It's just 2 records. It has these headers, OCN, barcode, and local title. It's got some really messy OCLC numbers, then OCOLC, OCN. It's got some really made up barcodes. And then I've got these also somewhat useless local titles, but this is just for the example. Okay, so as I mentioned this a few times, at the top of your script, you're going to import a bunch of modules. In this case, I'm importing CSV, which is my comma separated values library. I'm importing regular expressions. I'm importing PyMARC, of course, and then I'm also using a module called sys. So sys is a module that enables you to pass arguments on the command line. So all the examples I've shown you and in the instructions that you've probably seen on the GitHub repository, when you're running a script, you just type Python, name of the script, and you're done. Because those scripts in them actually hard code the name of the file they need to act on. So it'll say like, with the open mark.marc file, do this. Well, there might be a situation where you need to make that the file you're acting on more abstract. I'm going to talk about this in more detail at the end, but just keep in mind, I'm pointing out sys right now because you'll see it at the end of the discussion of this script. And it's gonna make sense at the end there. Now I want to note too, I know some of you had some difficulty installing PyMARC as a module. CSV, re, and sys are all modules that come loaded into Python. PyMARC is obviously, as you might expect, it's sort of very specific to our needs, the library specific module. It's not bundled in with Python the way CSV, re, and sys are, more generic modules. So you shouldn't have to do anything at all to get these on your computer. When you're writing your script, you just use this import line at the beginning of your script to tell your script to look for those modules within Python. Okay, so we're getting really fancy here with this script example. We're actually going to define a function. And again, this has to do with sort of abstracting out the script that we're using so that we can reference the file that we're going to be acting on, in this case, the CSV file, on the command line rather than hard coding it. So this is the syntax that you would use to define a function. Now, functions are nice because they put a lot of activity into sort of a chunk of code that you can then reference in other areas of your code. This particular file that we're working with only has one function. It only has one argument. We'll talk about what the argument is at the end. So it's very, very simple. But I wanted to provide this example so that you could see what a function looks like as you go forward using Python, and you might start building multiple functions into a single script and then calling them all at once. We're going to open up our CSV file. There's that open. Again, here's my FH that I just reuse over and over. We're going to read, in this case, the CSV. This is a variable I'm creating to store the fact that we're reading the CSV file. And we're going to create a list of items. So this could potentially be used actually with multiple CSV files, not just a single one. Here we're creating an output file. So this is a variable that I'm creating to store my open MARC file that I'm creating. The MARC file is going to be called writer.marc. WB there, if you remember RB from earlier, that was read binary. Now we're going to write a binary file. Okay, so now we're going to iterate through each row. So that syntax for record and reader. This time we're dealing first with CSV, we're not dealing with MARC records. So now we're looking at CSV files, we're going to go for each row in the CSV file. We're going to create a PyMARC record object. So for each row, we're creating a record. That's what this PyMarc.record is doing. And then we're defining data fields in each CSV file. So remember my CSV file from the beginning, I had 3 columns, OCN, barcode, and LTitle. It's always going to start at 0. So my row 0 is literally column 0 of each row, if that makes sense. So it's my first column. Remember when we count in Python, your first thing, whatever it is, your first character, your first column, that's 0. The next one is 1, and the next one is 2. So I'm defining my data fields in my CSV file. Here's our friendly regular expression that's going to clean up our OCLC numbers and only leave the numbers. And again, here's the OCN is just my variable that I'm using to store them. And now this gets a little bit, this might look a little scary looking, but all we're doing is we're creating PyMarc fields. We're storing these as variables that I've defined. You can call these whatever you want, field 001, field 974, field 949, that's how I've called them. But it's equal to a PyMarc field. The tag is the mark tag. The data is the variable that we created earlier out of the CSV rows. And I'll show this whole script at the end if you're like completely lost, so you can kind of see how it all logically works together. Field 974, this one gets a little more complicated because we have some subfields in there. This is just our OCLC number, so it's just going in the 001. But in our subfields, I'm creating a 974. This is just like a local title in our system. It's a 974 tag. I've got blank indicators. Obviously, here's where you would put whatever indicators you're actually going to use. And here are my subfields. Notice that these are repeating. So subfield A is the contents of the LTitle variable. Subfield 9 is a static constant. I'm just going to say local. And then my 949. So if you're using load profiles that look in the 949 field for various item-related information, this is just an example where you might do it. You can define, again, your subfields here. And again, I'm calling the barcode variable to be put into that field. There's not much to say about this one. This is just part of the PyMarc library. I'm going to add the ordered fields that I just created, 001, 974, 949, to my PyMarc record object, and then create my output file. This is all just syntax that is included in the PyMarc library. So we're going to use that item load record object and write it to the file. Okay, so now this is where sys comes into focus, why I mentioned that. So we're closing the mark output file. Now I have the statement file equals sys arg1. So that is referring to an argument. So when you are working with a function in a file like this, you can use sys to basically say, when you're running this script, like don't tell me what record you want me, what file you want me to act on just in the script. Instead, when you call the script, normally you would do something like Python, you would call the name of the script markwriter.py, and then you're done, you just run it. But in this case, to actually call the function within the file and tell your function which file to act on, you run Python markwriter.py, and then you have just a space, and then the name of your input file. And this input file, records.csv, is included in the GitHub repository so that you can just run this on your own. You might need to re-download and unzip the existing repository that you have, or you can just download records.csv and markwriter.py on their own and just run them separately to see how this all works. Okay, so then you get these very, very simple MARC records. These are intended so that, you know, the kind of scenario you would have is just a match point, like an OCLC number, that's going to then input barcodes in item records and maybe add a local collection tag. This is sort of the example. Obviously, you could use this method to build very full, robust MARC records if you needed to. But in this scenario, we're just using the brief one so that we can create a load profile to batch load items. Okay, so why did we do all that? Why did we have a function and put the file name as a command line argument? Okay, so enabling the input file to be specified on the command line allows you to run the same script over different files without acquiring script editing skills. So for all of you taking this this webinar, maybe you're feeling super confident with Python, or not. Maybe you're needing some more practice. But if you're specifying it on the command line, other people in your department, you might have this sort of shared process. You've got this Python script sitting on a shared server somewhere, and you all have different files that you need to act on. Well, if you hard-coded the name of your input file, you'd either have to change the name of your input file, which then could get really messy if you're all working with different files and you rename them all the same file name, and then you don't know whose file is who. Or each individual user might have to go in and edit that file to tell each other basically that you're working on this different file. So by enabling the input file to be specified on the command line, you and your colleagues can place the input files you're using and process them via the command line without opening up or editing the script. You just say what file you're using on, you can put it on the directory. Okay, so I know that was a lot of information, and I'm going to go over just really, really quickly the GitHub repository and where those scripts live. And we are going to have time for questions. Let me get out of here. I just want to reiterate in our PyMARC workshop here. So this is the GitHub repository that I shared last week. We do have some new stuff in here. Here's our records.csv file. That's just that CSV file that I mentioned. You can download this guy. And then I have a couple of other ones. This markwriter.py. This is the one I've just gone over in great detail. And you can see it all come together. Here's our import statements at the top. Here's our functional definition. Note the indentation of all of the code within the function so that it's all sort of defined in there. We are defining the function. We're opening the file, creating an output file. We're iterating over each row in the CSV file. We're creating the MARC record objects. We're writing them. And then we're defining that our system argument is going to go in there. So if I'm in my directory, let me just make sure I'm in the right place if you guys can see this in my command line. Essentially, if I'm going to run my markwriter.py script, and I'm on a Mac, so I use the Python 3 syntax, I can just type in markwriter.py, and records.csv is my input file. Again, I downloaded that as part of the GitHub directory. And it's not going to actually tell me anything, but if I go into my directory, I will see this writer.marc file, and I think I actually have it pulled up here. There's marc edit, and apologies, this is crazy tiny, but this is ultimately what that file will output and look like. So within your directories, if you run that markwriter script with records.csv, you will end up with a lovely, very brief marc file. So that is how that works. Okay, so we are running a little bit short on time here. I could talk about this forever. So if there are any questions, if you are experimenting with the GitHub repository from this point on, and you have any questions, feel free to reach out to me on Twitter. You can send me an email. My email address is right there. So please keep in touch. It was really fun to put these scripts together. I hope that you find them useful. I'm certainly willing to help going forward with any Python related questions that you might have. So Eva, I'll pass it on to you if you've received any questions.
Okay, yeah. Can you recommend a good way to learn the indentation rules in Python 3? I can't seem to get it, and they put that relates to activity 3. And related to that, someone else asked, what is the indentation? Is it a tab or a certain number of spaces?
Yes, so it is definitely not a tab. Let me go back to an example here. Let me get out of here. So I think if I go here, yeah, this is my indentation example. So in terms of indentation, the key thing is to be consistent. There is no hard and fast rule of each line indent 2 spaces. What you want to do is just make sure that things are indented and aligned when they're indented. So never use a tab, I will say. Tabs can be inconsistent. Different text editors read and interpret your tab key differently. And so you can end up with inconsistent spacing that way. So definitely don't use a tab. What I usually do is every line I create, so let's say I've just typed for record and reader, and I know I'm going to do this for F and record, I will hit enter and then space space. So I usually indent 2 spaces for each line. And I always use the space bar, I never use the tab key. And in terms of the rules, there's really not hard and fast rules. Again, there's no like, oh, you have to always use 5 spaces or anything. What you do want to make sure is that if you have if-else statements, those are aligned. And also, you know, of course, I mentioned this in the last webinar, you do want to make sure you're using a plain text editor, something like BBEdit or Notepad++. And both of those editors have functionality in them that allow you to view hidden characters. And that's really useful for troubleshooting. Sometimes there'll be like a weird extra space or a hidden weird character in there that you can't even see with the naked eye. And so you can, I can't remember if it's BBEdit or Notepad++. One of them has a function that's like view gremlins or something. And it's like these weird character spaces or issues that might show up. So if you are having problems with activity 3, please do send me an email and we can maybe work it out over email, or I'm always happy to hop into a Zoom session. We can figure it out with the indentation thing. But it really is just a trial and error. Avoid your tab keys and look for those hidden characters if they're still getting in your way and you can't see any issues with them.
Okay, someone else, I think this was back at the beginning, asking about F being a variable. What is its meaning and where do you define that?
Yeah, so it might have had to do with something that's more like in this example where F and FH. So this is really just like F is, it's made up. I think it's used often in Python because it's like, it's just there's probably some reason to it that I just don't know, but I see it often in scripts, some variation of F or FH. But you're basically just creating any, you can use any word or set of letters there. You could use B or X or J, it doesn't matter. So you're storing essentially, in this scenario, you're opening the file and you're storing that open file as F, FH, something like that. And then you're referencing it down here. So our MARC reader is acting upon our open file defined as FH. There's ways to write this that wouldn't use this exact statement, where you would just do reader as MARC reader, and within that parentheses you could have like open the MARC file or whatever. But this particular syntax kind of cleanly separates out exactly what you've done. On that first line, we're opening the file, we're storing the open file as FH, and then we're running MARC reader against it. So the fact that I use F or FH in my particular scripts is not prescriptive by any means. You can use whatever variable, name, letter you feel comfortable with. Does that answer the question?
Yes, I think so. And we just have time probably for one more. Oh, I think she's saying, but what is it doing in this example?
Well, so in this particular example, this looping through fields example,
the plain F.
Just the plain F, so that must have been probably at the beginning. Let me see.
Well, there was one in that example.
Oh, for F and record. Okay, that's doing the exact same thing. Yes. Okay. So, so again, it's doing a very similar thing here. This is basically for each. If you're familiar with that sort of syntax in other programming languages, you would say for each. For each record, get the field. That's sort of the way that I would translate this. For each record, get field 020. And this is, again, just a totally random name for a variable that you can use. You can use any letter combination. So it's storing the fact that we're getting all of the fields. So you can really read this. So you can see how in this line here, if F subfield A is not none, F is essentially the MARC field 020. So for each 020 field, F is just storing each instance of the 020 field that we're then acting upon in the next line. So again, F could be any letter you want. It's basically just storing the 020 field so that we can act on it in the next conditional. Does that make sense?
It does to me.
Okay.
Okay, I think that's all we have time for, but we'll have Lauren answer the rest of the questions that came to us offline, and we'll send them out to all the participants. So thank you, Lauren, for your second webinar on Python and PyMARC. I think it's going to be really useful. I'm excited to try it. Thank you to all our attendees. We hope you found today's session useful. You will soon receive a short online evaluation form along with links to today's recording and slides. Please take a few minutes to respond to the questions and return the form to us. Your comments are very valuable and help the ALCTS committee improve its webinars and help plan future events. ALCTS now offers certificates of attendance to webinar participants. More information on this will be included in the email you receive. Information about all ALCTS webinars can be found on the ALCTS homepage. Please check out our web courses and upcoming e-forums. Suggestions for webinars and other continuing education opportunities are welcome at any time. You can contact any member of the ALCTS committee or submit a proposal for a webinar using the online form on the ALCTS webpage under Online Learning. I would like to thank Mary Aycock and Wanda Jazzieri for providing technical support for today's webinar. The support they and their colleagues on the Technical Support Subcommittee provide make it possible for us to present these webinars smoothly. Thank you again for joining us this afternoon, and we hope you will participate in other ALCTS CE events in the future.